Homes are getting smarter, but that also means they're getting more complex. This complexity increases the more connected devices get added to home networks. With this added complexity comes an increased security risk, because every new smart thing is a possible trapdoor for nefarious outside parties to hijack control of your devices, holding your personal data hostage, or using them to target a host on the other side of the world. The most severe security vulnerabilities for IoT devices come from poor management of these devices. This is why hackers are able to exploit weaknesses caused by out-of-date software and default passwords. Moving the burden of device management off the shoulders of the consumer is therefore a promising way to make these devices more secure in the future. If a hacker is able to break into an IoT device, they can reprogram it easily because of a lack of built-in restrictions that would limit its functionality to only intended uses. However, if a device came from the manufacturer with these restrictions in place, it would be much more secure by default. This is where the IoT Hub comes in. Our solution is designed to provide the means to enforce these kinds of restrictions while also reducing the burden of managing dozens of in-home IoT devices. Similar to the way in which a smartphone's operating system manages permissions and controls for many individual apps, our IoT Hub gathers an entire network of connected devices into a single endpoint that the user interacts with, which is the interface of the hub itself. Our design takes advantage of metadata for IoT products known as the Manufacturer's Usage Description, or MUD for short. This metadata can take several forms, and the Internet Engineering Task Force is currently developing a standard format for this data. When a new device is added to one's home network, a URL stored on a small web server on the device is sent to the hub, which then fetches the device's usage description, its MUD, from the manufacturer's website. This file includes three types of data. The first is static information, including model number, manufacturer, and, importantly, permitted websites. The second is dynamic information, such as device name, battery level, and, importantly, current software version. The third type of data appearing in the MUD is a list of functions that the device is able and allowed to perform, such as turning on, fetching information, and displaying that information. This metadata file can come in the form of standard XML tags or JSON objects, so they are easily created and easily read. In this demonstration, we are connecting a smart coffee machine to the hub using a mobile phone screen to display the hub's interface, and another mobile phone screen on the coffee machine itself to display the device's activity. The homeowner first tries to connect the coffee machine before adding it to the hub's database. As you can see, the coffee machine is unable to access the internet. Next, the user adds the device using the hub. This coffee machine does not have a URL for its usage description, so we show that it is possible to enter the same information that would come in the MUD manually into the hub's database. Now that the smart coffee machine's metadata has been stored in the hub system, it can see that we've allowed this particular coffee machine to go to Carnegie Mellon's website. When it tries to post to Facebook or gets pointed to any other site, access is denied. Limiting a device's access to the internet is only part of the battle. The other key feature of the hub is facilitating software updates for each device it manages. Two of the values stored by the hub are the current software version a device is running and the URL to go to get software updates from. Periodically, the hub checks that URL to compare the latest software version to the current version, and if they are different, the hub alerts the user that their software is now out of date. In our current implementation, the user must update the software themselves, but in future versions of the hub, we anticipate it performing these updates automatically, just notifying the user that the update has taken place. For the ease of demonstrating our concept, the IoT Hub software currently runs on a web server, but ultimately we envision this software and database running on a wireless internet router itself, so no extra hardware is needed between the devices and the router that connects them. The IoT Hub plus the MUD combine to create a network of in-home IoT devices that's more secure, more scalable, and more manageable for today's and tomorrow's homeowner.